Okay, for this question, let's try a very simple fundamental question to see if you understand how to govern a transfer function from a translational system. Okay, imagine we have a mass, right? Let's say a 5 kg on a plate or on a surface where the friction is maybe 2 Newton second per meter, and then we have a string or a cable pulled by a force, certain force lah, right? This cable has a stiffness. This cable has a stiffness of, let's say, 10 Newton per meter, right? 10 Newton per meter. So this is a very basic example lah. So just ignore if the value is inappropriate. Just ignore. So we want to govern an equation of motion or a transfer function to describe a relationship of F, the force, and the movement of X. So we want to find the transfer function of relationship between what happened to X when F is changed. Okay, so you can pause the video to try to solve this one first on your own, and then after you try, you can come back to the video to see the solution. Okay, so I hope you try on your own first before you see the solution, right? So we can redraw this in a schematic diagram of a mass, right? We have a mass 5 kg, and then we have a force acting on the cable, but the cable have a stiffness of 10. Okay, so we have a friction of Fv equal to 2. Okay, so when we try to solve this, we need to find the degree of freedom of the system. So this system, there is a possible movement of X, and there is also another possible movement or a degree of freedom at this point, X2. Okay, so this problem, although has only one mass, but this is actually a 2 degree of freedom system, because imagine if you can move this point without moving this point, right? You can move this point without moving this point because of the cable stiffness. Okay, so we need to analyze both. The first one, right, we have mass, friction, and spring force. So for mass 1, the free body diagram will be, right, mass 1, the movement to the right, friction to the left, Fvx1 dot, and then we have a spring, so Fv is equal to 2 lah, and then we have a spring. We also try to pull thing, the spring will also try to push, right? Although this one, the force is acting to the right, but because we try to imagine that what if this mass is moving to the right, because we assume x1 is positive, so the spring will try to push back, and we get 10 x1 minus x2. Okay, which means that any movement to the right, a positive movement of x1 will make the spring push back to the left lah. Maksud dia macam tu lah, the meaning. And whenever the spring x2, whenever x2 is moving to the left, we'll also try to push the mass 1 to the left. Okay, so we list out all the forces, then we get 2x.1 negative to the left, minus 10 x1 minus x2 equal to m1, which is 5 x double dot. Okay, so for the first equation, we do Laplace transform again, and then we rearrange, so we get 5s squared plus 2s plus 10 x1 minus 10 x2 equal to 0. Right? So this is the first equation of from the equation of motion of mesh number 1. And then we have at point 2. So we need to analyze at point 2 as well. So at point 2, we have a spring and the acting force. So force to the right minus the spring force will be to the left lah. So minus 10 x2 minus x1. No friction equal to no mass equal to 0 lah. Okay, so rearrange the equation, we get 10x2 minus 10x1 equal to Fs. Okay, so we have two equations to solve. Okay, we have two equations to solve. Then we want to find the relationship of x1 and x2. So this equation 2, this equation 1 should be very easy lah, because we already have same terms, so we can just simply 2 minus 1 to get the relationship of Fs and x1, or 1 minus actually 2 plus 1 lah kan. So we want to eliminate this term, so taking equation 2 plus equation 1, so we get negative 10x1 plus 10x2 equal to Fs plus 5s squared plus 2s plus 10 x1 minus 10x2 equal to 0. So this minus will cancel out, this will become Fs. So negative 10x plus this, so we get 10, so we have 5s squared plus 2s, right? So if my mathematics is right, okay, we will only live with this term lah, because 10 is already cancelled out, and then we have 5s squared plus 2s times x1 equal to Fs. So relationship of x1 divided by Fs is equal to 1 over s 5s plus 2. Okay, so this is our final transfer function to describe the movement of this system.